Today, we shall be looking at solving for x. We shall be looking at solving for x and y simultaneously. We shall be looking at um, how to determine, without the use of a calculator, the value of an expression that arises. So this is part of the curriculum, and this is a national curriculum. Right, solving for x, we begin with the simplest and we build to the most complex. X squared minus 7x plus 12 equals 0. And we want to solve for x. How do we solve for x? Right, so to solve for x, first things first, we need to factorize the expression. So we write a product of two linear factors, and we have a biconditional where the factors of x squared become x and x. The factors of 12, of plus 12, that give exactly minus 7, minus 4, and minus 3, respectively. At this point, we're able to see, therefore, that x equals 4 or x equals 3, and these are the values of x for this equation, and the marks allocated are 3. So you will write the notes at the end. We need to solve for x in the next question, given this expression. Right, and this expression is actually must be solved corrected to two decimal places. So what we have therefore is that we have exactly 3x squared plus 5x minus 1 equals 0. So you need, right, the quadratic formula. Once the examiner says correct to two decimal places, what does the quadratic formula say? So it says minus b into, right, minus b plus or minus the square root of b squared minus 4ac all over twice a minus, okay, given the quadratic equation, we see that clearly a is 3. So in other words, you have 3x squared plus 5x minus 1 equals 0. So you have ax squared plus bx plus c equals 0, in which case you have a equals 1, 3, excuse, right. So you have a equals 3, which is exactly that one. We have b equals 5, and we have c equals exactly minus 1. Okay, in which case we substitute our b there. Well, b is 5 plus or minus the square root of the b squared, which is exactly 5 squared minus 4a is 3. And then our c is exactly minus 1. Right, so we actually divide by twice a is exactly 3. Now note, a couple of things remain extremely important here. So what is extremely important? So we need to be in a position to solve this equation. So to solve this quadratic equation, we proceed as follows. We use our calculator at the moment. The calculator is therefore used to obtain what is under the radical sign or the square root sign. So the square root sign will have under it exactly 37. Okay, if you use a calculator as well to get what is under the square root sign. Okay, from which we have those two results. And so we are able to see, therefore, that thus the answers are as follows. What is the x? X is exactly minus 5 plus the square root of 37. You divide by plus 6, or x is minus 5 minus the square root of 37 divided by 6. Or what is the answer? 0,18. 0,18 is the result here. Okay. Or if you use a calculator, minus 5 minus the square root of 37 out of 6. Okay. The calculator will give you precisely minus 1,85, like this. Okay. So we have that. Right, so this has been solved to correct 2 decimal places. Right, so once again, this is recorded. So I'm not expecting you to copy anything down at the pace at which you move. Right, so we need to solve for x. We've been given a quadratic inequality at this point. And these quadratic inequalities, x squared less than minus 2x plus 15. Right, this is part of the curriculum and part of what must be done in grade 11 according to the National Qualifications Framework. Right, so we have x squared plus 2x, we subtract 15, and the result is less than 0. Right, in other words, this is true in both directions, and hence we can proceed in both the forward and the reverse directions. Right, we actually therefore are able to factorize these quadratic inequality, the quadratic expression, in actually into a product of 2 linear factors. The factors of x squared become x and x. The factors of minus 15 becomes plus 5 and minus 3. Okay, so you know that the factors of minus 15 are 5 and actually minus 3. In which case, therefore, we get 2 entities, and the entities we call actually critical values. Right, what are the critical values? They are x equals minus 5 or x equals 3, okay? So these are the critical values. After we got the critical values, we sketch a rough diagram, and this rough sketch demonstrates the actual critical values on the number line x. Right, on the x-axis, we just only draw the x-axis, we would not draw the y-axis, we would not have much time. The marks allocated in the exam are only 4. Right, so we put this on the number line, and we have...
Sorry, sir.
Yes, please.
The 2 numbers must always add up to the b.
Yes, thank you so much. The 2 numbers,
And
namely the 5 and the minus 3 must add up to the b. Okay, so well done there. And they do, because we can see that we take 5 and then we are adding it up with minus 3, and the result is 2, and the 2 is our b. You agree? Okay, so now that's extremely important, because those 2 numbers add up to the b. Okay, right, so we are in business here. We're good. What are the critical values? Okay, we plot them here, and we plot minus 5, we plot 3 there. Okay, so now what are the solutions at this point? Right, so we actually need to indicate on this number line here that x, so we put open circles here. We don't shade these circles, but moreover, we realize therefore that this is less than 0, and less than 0 means we are dealing with a negative expression. Negative expression is is below, because now above the x-axis is positive and below it's negative. So we are looking at the part that is at the bottom of the x-axis. So we have this. So at the bottom of the x-axis, therefore, we have that minus 5 is less than x less than 3. Note what is happening here. So we actually therefore draw a rough diagram, but you realize that this quadratic inequality is saying less than 0. So in other words, we're dealing with the negative part of the parabola, because the x squared plus 2x minus 15 is actually a parabola. In less than 0 will therefore demonstrate the bottom part, and the bottom part therefore will be minus 5 less than x less than 3, and therefore we have the result. And what is the answer to the question? The answer to the question is therefore that x is actually lying between, or x lies between minus 5 and plus 3. And this is the solution to the quadratic inequality. So please make sure you understand that. we're yet to spend a bit more time on solving a lot of quadratic inequalities for you to build enough confidence. Okay, part of the exam requirement is the ability to solve problems that involve radical or radicals. So in other words, radical equations. Right, so how do we solve this particular radical equation? So to solve this radical equation, we proceed as follows. So you have 2 into 1 minus x, like this. And now we square on the left and we square on the right. We square on the right, in which case, okay. Right, if you square both sides, that is, because why do you square both sides? You do that to remove the square root sign, in which case, therefore, you have 2 into 1 minus x. Right, so you have the square here to perform. If you square the x minus 1, it's called a binomial expression. Pi means 2 for the 2 terms up there. So you have x squared. The next thing is you take the number 2, you multiply by x, you multiply by minus 1. So you multiply the number 2 by x, you multiply by minus 1. So is one way to quickly expand this one here. The next thing is you square this. So you always put a plus, but always, and then you square that. And that will allow you to square this with ease, okay? Right, so if you square the left, the square root goes away, giving us 2 minus 2x, which is exactly x squared minus 2x plus 1. So, which is exactly x squared. And then now we group like terms. So we have x squared. We transpose the minus 2x to the other side. It finds on the other side minus 2x, and we add 2x plus 1. And then we have minus 2 equals 0. And then we have x squared minus 1 equals 0. Okay, good. We are here now. And this is awesome. From grade 10, we need to remember something we've learned called the difference of two squares. Right, so the difference of two squares. What is the difference of 2 squared? A squared minus b squared, which is a minus b into a plus b. So this is called the difference of 2 squares. Right, so we have it here. And we're going to use the formula from grade 10. So we have x squared minus, we square the 1 equals 0. Right, so if you have a difference of 2 squares, you cover the squares, and then you're left with a minus b, which you put there. So we cover the squares, and you're left with, if you cover the squares, you're left with x minus 1. Then you put the a and the b, but you just put the opposite sign. And the opposite of the negative sign is the positive sign. So you'll have the positive here. Okay, so you'd have exactly that. So you'd have exactly x plus 1. Right, you'd have x plus 1. So you'd have x plus 1 equals 0. So you have x equals 1 or x equals minus 1. Right, so upon analysis, if you take the minus 1, you put it here, it becomes minus 1, which is minus 2. And therefore, we can see, therefore, that this one is not going to work because the square root, by definition, must be positive. So the square root of anything in mathematics, the square root of 4 is only plus 2. But now if you put, so in other words, we realize that x equal to minus 1 is actually inadmissible. It is inadmissible. Okay, or it is not applicable, or it is invalid. Right, so what is the answer to this question? It is exactly x equals 1. And this is the answer to the radical equation. Right, next, we continue to solve the next problem. Right, solving the next one can be done with ease. Right, we must be in a position to solve simultaneous equations as well as part of the curriculum. And these are past exam questions. And it's very important that we strive to reach the level of assessment and questioning reached at national level. Given these two simultaneous equations, how do we begin to solve this? We proceed as follows. Right, so we have these two equations, and we'll start by looking at 3 to the power x plus y equals 27. This means we can write 3 to the power x plus y. The 27 is 3 cubed. If the bases are the same, we equate the exponents. So the exponents are x plus y equals 3, and this clearly gives us equation 1. Which means x squared plus y squared equals 17. So you have that this is 17. So you therefore, from the first equation, you can transpose x so that we obtain minus x plus 3. Look at the first equation. It is x plus y equals 3, but if you transpose the x, it will attain a negative sign in front, making it minus x plus the 3 on the right side of the equation. And this becomes equation 3 of the simultaneous equations. Okay, dealing with the simultaneous equations, we're able to do substitution. So we substitute equation. We substitute equation 3 into equation 2, right? And if we do that, we substitute equation 3 into equation 2. Into x squared is going to remain x squared. The y is going to become minus x plus 3, which is square. And this is 17. Let's continue to manipulate this equation here. Okay, so if we carry forward x squared, we square the x squared, we multiply this one. And what is x squared plus x squared? It is 2x squared minus 6x minus 8 equals 0 there. Okay, we need to factorize this, but to factorize this, we divide through by 2. Dividing through by 2, we get x squared. If you divide 6 by 2, you get 3. Divide 8 by 2, you get 4. Right, so this becomes x squared minus 3x minus 4 equals 0. It's a quadratic equation which must be factorized into a product of two linear factors, vectors of degree 1. And therefore, the factors become the following. Right, the factors of minus 4, which when you add, give minus 3. They are minus 4 and plus 1. They're minus 4 and plus 1. So x equals 4 or x equals minus 1. So we have these. So which means at this point, what do we have? Y is minus x plus 3. From y equals minus x plus 3, we're able to get that x equals 4. When x equals 4, you would have that y is minus 4 plus 3. What is minus 4 plus 3? It is minus 1. When x is equal to minus 1, we shall have that y is exactly what? Right, so we substitute into the equation this one. So it's minus into the y is minus 1. We add the 3 there. And therefore, we have that our y equals 4. This lesson is recorded. Okay, right. So these are the solutions to the simultaneous equations. What are the solutions? So we have that x is 4, right, or x is minus 1. We have that y is minus 1 or y is 4. Right, so we have solved this and you shall have a chance to go through it again, watch this video, etc. and take down notes. Okay, the next question is, we need to cultivate the ability to solve certain equations that are that involve radical expressions through the method of rationalization. So how do we rationalize? How? For now, so we have 2, which is the square root of 1 minus the square root of 2, divided by the square root of 1 minus the square root of 2. Look at what I've done. Okay, we have the square root of 1 plus the square root of 2 in the denominator of the first term of the series. So they gave a series in this question. What is a series? A series is a sum. A series is a sum. If we agree that a series is a sum, then we can be in a position to deal with this and solve successfully. Right, so this is plus. So you have 1 divided by the square root of 2 plus the square root of 3. You multiply by the square root of 2 minus the square root of 3. So you put the opposite sign. Why are we putting the opposite sign? It was plus here and we put a minus there. All right, and it's plus here and we're going to put a minus there. Right, so we have this. Plus the square root of 4 multiplied by the square root of 3 minus the square root of 4. The square root of 3 minus the square root of 4. So we are here. We are rationalizing each of the terms. Note that here we have the square root of 1 plus the square root of 2. We multiply by a disguised 1. So this divided by this is 1 because you're dividing this by itself. But you need to note that at this point, we're multiplying this by that. We're doing the same because the sign is positive here. It's positive, you multiply by the negative. Positive, you multiply by the negative. Okay, so we continue. Right, so it's plus dot 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 plus 1 divided by the square root of 99 plus the square root of 100. So this is the square root of 99 minus the square root of 100. We divide everything by the square root of 99 minus the square root of 100. So this is the square root of 1 minus the square root of 2. So if you multiply these by that, okay, note this. This is like the difference of 2 squares, because difference of 2 squares, we remember that again, and we bring it here. Difference of 2 squares. How does the difference of 2 squares actually work? If you have a minus b into a plus b, it is the same as a squared minus b squared. So you multiply these and that. So that is going to be, if multiplied by the square root of 1 by the square root of 1 becomes 1, the square root of 2 by the square root of 2 becomes 2. But if it's plus times negative, it's negative 2. Okay. So you continue. We continue. Plus, this is the square root of 2 minus the square root of 3. So this and that becomes square root of 2 times the square root of 2 is 2. Square root of 3 times the square root of 3 is only 3. Positive times negative is negative. Okay. So we continue. We multiply this with that, which is the square root of 3 minus the square root of 4. Divided by square root of 3 by the square root of 3 is 3. The square root of 4 by the square root of 4 is 4. You put negative here. Right, so you deal with this one here, it becomes the square root of 99 minus the square root of 100. So you multiply this by that, it becomes 99 minus 100. So what is 1 minus 2? Is minus 1. So if you divide this by minus 1, it's going to make the square root negative, the square root of 1 negative. But if you divide by minus 1, it's going to make this one positive. This is going to make this one negative, and this is going to make this one positive. So this one is going to make this negative, and this is going to make this positive. So you can see the signs sort of alternate. It's negative, positive, negative, positive, negative, positive. Then the next must be negative. Then you put the ellipses like this. Right, next you have 99 minus 100, which is exactly minus 1. If you divide the square root by minus 1, it becomes minus 99 square root. And if you divide here by the negative, it's going to become plus. Because negative divided by negative is plus. At this point, we continue to simplify this here. So you can see that the square root of 2 cancels the square root of 2, the square root of 3 cancels out, so the square root of 4 is going to cancel out. We shall be left with only the square root of 10, of 100, excuse me. So this is exactly the same as minus 1 plus the square root of 10 of 100, which is 10. What is 10 minus 1? It is exactly 9. So what is the answer to this equation? The answer to this equation is clearly a 9. Is clearly a 9. Right, for 3 marks, we're done. Next question. Right, so we have question 2. Question 2. Right, question 2 is very simple, but it is based on sequences and series. So the concept of sequences and series is a very important one. The first question is about geometric series. The next question is about a sum to infinity, arithmetic and geometric sequences and series that have been combined to form the pattern, which are given by the Pn, and you calculate the value of P26. Right, let's look at 2.1.1. Is this a convergent geometric series? Is this a convergent geometric series? Right, so at this point, because it is a convergent geometric series or not, we need to determine that. But first, we realize that justify your answer with the necessary calculations. So when we have a geometric series, there's something we call the constant ratio. What is the constant ratio? The constant ratio becomes the second term divided by the first term. Right, so what is the second term? It's 1/15 divided by 1/5, like this. All right. Okay, continue. So we continue now. We have 1/15, which is 1/15. So you multiply by 50 by 5/1. So look, when you are dividing two common fractions, so what you do is you take 1/50, you multiply by 5/1. So this is 1/3. Oh, if this is a convergent geometric series, justify your answer with the necessary calculations. So the ratio is that one. So is it convergent or not? So obviously we note therefore that at this point -1 must be less than the constant ratio must be less than +1. So -1 is less than the constant ratio, and the constant ratio is 1/3, and it's less than 1. Look, the number 1/3 is the same as 0.3 recurring. 0.3 recurring actually is 1/3. And this 1/3 lies between -1 and 1. Okay. And this is clear. So at the end of the day, therefore, hence we conclude. Hence the series. Hence the series is convergent. Hence the series is convergent. So at this point, therefore, we have a convergent series. We have a convergent series. Okay, because what was the question? Is this a convergent geometric series or not? So we have a convergent geometric series. Okay. Let's look at the next question. Let's look at the next question. What is the next question? Right. Okay. Given the geometric series, this one, we need to calculate the sum to infinity. How do you find the sum to infinity of this series? What is the examiner asking us to do? To calculate. What are we calculating? We are calculating the sum to infinity of the series. What is the formula? It is the sum to infinity, which is a divided by 1 minus the constant ratio, where we agree that the constant ratio lies between -1 and 1. So which means the sum to infinity is the same as the first term of the expression. So the first term is called a, and a is 1/5. 1 minus the constant ratio. We found the constant ratio. What was the constant ratio? Is 1/3. So you have 1/3 here. Okay. 1/5. What is 1 minus 1/3? Right, 1 minus 1/3. So we have 3. So you can call this out of 1. 3 divided by 1. is 3. By 1, it is 3. You bring down the negative, 3 divided by 3 is 1. By minus 1 is minus 1, which means this sum to infinity can be written as follows. You can write downwards, but you can write across the page. Across the page. So you have 1 out of 5. You divide by, what is 3 minus 1? It's actually 2 out of 3. This is 1 out of 5. You therefore multiply by the reciprocal. The reciprocal is 3 out of 2. In these is 3 by 1 is 3. 5 by 2 is 10. 3 out of 10. 3 out of 10. So the answer is 3 out of 10. Okay, let's look at the next question. Okay, what is the answer 3 out of 10 meaning? What is the meaning of this? Well, the answer 3 out of 10 means that we are dealing with the sum to infinity, and the sum to infinity is 3 out of 10. Okay, so we're done. Okay, sometimes the examiner asks us a couple of questions, like we have been given an arithmetic sequence and a geometric sequence. Okay, these are combined. So sometimes they combine arithmetic and geometric sequences to form one sequence, to form a single pattern, which is given by, okay, the pattern is given by P sub n, P subscript n, which equals x, right? 1/3, 2x, 1/9, 3x, 1/27th, and so on. And the examiner is saying, write down the next 2 terms of the pattern. What are the next 2 terms of the pattern? So the next 2 terms of this pattern will be given by the following. Well, the next 2 terms will be given by, okay, so you see, this one is x, after x is double x, so we're adding x, and then we added another x. So if we add another x, you're gonna get a 4x, and then this one is 1 out of 3. 3 squared is 9, 3 cubed. So this is like 3 cubed in the denominator. This is like 3 squared. This is like only 3. This is like 3 to the 4th power. So what is 3 to the 4th power? It's exactly 81. So which means, what are the next 2 terms? So write down the next 2 terms. So the next 2 terms are given as follows. Right, so they're given by for x and 1 out of 81 for 2 marks. We continue to look at the next question. What is the next question? Right, so the next question is as follows. Right, we have an arithmetic and a geometric sequence obtained, rather combined. So we combine an arithmetic and a geometric sequence. They've been combined to form a pattern. The pattern which is given by Pn equals x, 1/3, 2x, 1/9, 3x, and 1/27. Determine the general term for the odd terms of this pattern. Right, so let's continue now to look at these. So if we want to find the general term for the odd terms of this pattern, we proceed as follows. Write down your answer in terms of x. What is your answer in terms of x? Right. Sorry. If we're looking at the odd terms, what are the odd terms of this pattern? So we're dealing with this one. This is T1, this is T2, this is T3, this is T4, this is T5, this is T6, and so on. So the odd terms the examiner was referring to is like odd numbers. Odd numbers, what are odd numbers? Okay, there are certain numbers that are odd and there are certain numbers that are even numbers. Odd numbers are the numbers 1, 3, 5, 7, and so on. There are certain numbers which are regarded as even numbers. What are even numbers? Even numbers are the numbers 2, 4, 6, 8, 10, 12, and so on. Okay, beginning with the least 0. So now we continue and we solve the problem. We need to find a general term for the odd terms. Or the odd terms would be x, and then double x, and then 3x, and so on. So these ones here, if you look, if you look at T2 minus T1, and you look at T3 minus T2, what is T2? Is 2x minus T1. So this is only x. T3 is 3x minus 2x, which is only x. So which means you have the common difference. So what we have? We have something we call the common difference. Right, so this common difference is d, which equals x. All right, so if this is the case, what next do we do here? So the formula is that Tn is a plus n minus 1 equals d. This is the general term for arithmetic sequences and series, so that the first term is x plus n minus 1. The common difference is x. We found the common difference, which is exactly x over there. And then now this here is Tn equals x. You multiply it through by the x, and this becomes nx minus x. And if you simplify this here, it becomes exactly nx. We divide the whiteboard accordingly so that we're able to see that Tn is the same as nx. All right, if Tn is nx, this is what we have. This is what we have. Okay, this is exactly what we have here. What was the question? The question said determine the general term T sub n, or Tn, we sometimes call it. And so the general term is Tn is equal to nx. Tn is equal to nx. Tn equals nx. Okay, we're done with this one. Let's get the next question. All right, 2.2, an arithmetic and a geometric sequence are combined to form the pattern which is given by that. Calculate the value of P26. Calculate the value of P26. So how do you find the value of P26? Right, to find the value of P26, we proceed as follows. So now you need to be very careful here that if we have all these terms, there's P1, because Pn is x, there's P1, which is x, P2 is 1/3, P3 is this, P4, P5, P6. So P26, we note that P26 is actually is a geometric term. It is a geometric term. So which means Tn, or the geometric sequence term, you can call it the geometric sequence term, which means AR to the n minus 1, which means you have the first term, right, of the geometric. What is the first term of the geometric pattern at this point? Right, so if you're dealing with a geometric, this is a geometric, you have 1/3 here. After that, it becomes 1/9, which is 1/3 squared. That we have this one here, 1/3 cubed. Okay, 1/3 cubed. And the pattern continues. Okay, if this pattern continues, we have A, which is the first term. So in other words, A equals 1/3 is the first term. Right, after we got the first term, we must get something we call the common ratio, or what they call the constant ratio. R, which is T2 on T1. What is T2? Is 1/9 on T1 is 1/3, and therefore is 1/9. You divide 1/9 by 1/3. So you multiply by 3/1, the reciprocal of that. 3/9, which is 1/3. So the common ratio is 1/3, and then it is n minus 1. So if you add these things, it's 1/3 to the power n. So what is the meaning of this? You move across the board like this. So you'll be able to find T13. What is T13? So it is actually what we get. So T13 is going to be exactly 1/3 to the power 13. Right, so 1/3 to the power 13 means that T13 is actually 1 out of, okay, because you can raise 1 to the 13, but also 3 to the power 13, which is 1 to the power. 3 to the 13 is 1,594,323. And this can be written in scientific notation because you're a science student. So it is 6,27 times 10 to the minus 7. Alternatively, you can write these as 3 to the power minus 13. Okay, because you can just reciprocate the 3 to the power 13, which is 3 to the power minus 13. So this is the answer. Okay, so this is what we get. So this is the answer to the question. Right, so because it is T26, So we do T13. Why are we calculating T13? Why T13 from P26? Why 13? Because we realize that 26 divided by 2 will give us what? Will give us the number 13. But also because this is a combined series, one term is of the arithmetic sequence, the next one is geometric, arithmetic, geometric, arithmetic, geometric. So half will be arithmetic and half becomes the geometric sequence terms. Okay, we continue and do the next one. 224. An arithmetic and a geometric sequence are combined to form the pattern which is given by. Okay, so if we have that the sum of the Pn from 1 to 21 is 33,5, determine the value of x. Determine the value of x. Determine the value of x. Right. Right, so what do we have here? Right. Okay, want to find the value of x, and how do we do that? Right, how do we do that? We continue with this one. Right, so if we have that this is a summation and we want to find the value of x, how do we find it? And this summation sums all the PNs and the result is 33,5, and you need to determine the value of x. Right, how do we find the value of x? Okay, how do we find the value of x at this point? We can be able to find the value of x. Right, so the summation from 1 to 21 is 33,5, determine the value of x. So we need to realize that if you add up to 21, just imagine that you are adding up to 20. Right, so if you're adding up to 20, what will it give? If we're adding up to 20. So it will mean, therefore, okay, if you have the summation of these now, you'd have the sum of the 11 terms and okay, if you have 21 terms, just imagine you're adding up to 20 terms. So you'd have up to 20 terms, like if you add two, if you have two terms, you'd have one arithmetic, one geometric. So if you add up to 20, you'd have 10 arithmetic, 10 geometric. Because if you add up to 20 terms. But if you add up to 21, then the odd one is going to be the So in other words, it's the same as saying you have the sum of 11 terms plus the sum of what? Of 10 terms. All right, so okay, so you continue. You continue. So what is the meaning of all this now? We're here to engage more. It means therefore, if you add up to the like if you could stop at 3, you could stop at the odd one because it's T1, T2, T3. Right, so the sum of the 11 terms would be the same as, okay, there are certain formulas we use for the arithmetic series. Okay, the word series means a sum. It's just a mathematical term that means a sum. And then we have another one for the geometric. So the arithmetic is going to be n over 2 into twice a plus n minus 1 into d. Okay, continue. Okay, so you have this one, and then you have this one, which is Sn is a into 1 minus r to the power n. So this one here is going to be r to the power n divided by 1 minus r. We continue. Right, so obviously this geometric, it's the understanding is that the common ratio cannot be 1 because we shall have a problem. Because if ever the common ratio is 1, then you have 1 minus 1 in the denominator, and 1 minus 1 becomes 0. So this one is the formula for the arithmetic. It's exactly n out of 2 into twice a plus n minus 1 d plus a into 1 minus r to the power n divided by 1 minus r. So the arithmetic ones will be odd. The first term of the arithmetic, x, you add x, you get 2x, you add x. When you keep adding, you have the arithmetic sequence, and therefore the first term is x here. And then you have n minus 1. Right, you have n minus 1. Right, so if you have n minus 1, what are we getting here? Right, so we continue. We continue. Okay, just a minute. Let me speak to someone here.
Okay,
Yeah.
so it's fine.
Yes, hello, Suman's mom. How are you? Yes, please. Yes,
Sunshine, he needs lessons like during the day, like today
yes.
at 6 a.m. in the morning.
Oh, I understand. All right.
Can you give him a lesson today, please?
Okay. Okay, yes. Okay.
Thanks, yeah.
I understand. Yeah. All right, that's fine. Yeah. I'm gonna fix the time. Okay, yeah. Can it be 6 p.m.? Maybe it's too late.
PM today is fine.
All right.
Today
All right.
6 p.m.
All right.
If you listen tomorrow,
Yes.
you just speak to my husband about whatever.
Okay, that's fine. That's fine. I will. I will. Okay, that's fine. I understand. I understand. Yeah, I understand. The exam is around the corner. Yes. Okay. Okay. Thanks, Aman's mom. Thanks, Aman's mom. Okay. Okay. Thanks. Goodbye. Thank you. Mhm. Hello. Yeah, we're right back. I was just speaking to somebody. My apologies. Okay. Right. So we have that the first term. What is the first term? It's x, right? And then you have n minus 1. What is n minus 1? N minus 1. Right. So we are dealing with 11n. N is 11. So you're going to have 11 minus 1. Okay, so we have that. The common difference is what? 2x minus x is what? Is x. Okay. What is the first term? Is 1 over 3. 1 over 3 for the geometric. The geometric is having the fractions. 1 minus. The common ratio is, we did that before. We got this 1 over 9 divided by 1 over 3 is 1 over 3. We did that before. The previous question, the sum of the 10 terms is 10. Okay. This is for the S10, means we're dealing with the 10 terms. Okay, we're likely to doing more complex questions. So, yeah, be ready. 1 minus 1 under 3. Or we have this. Right, so what is 11 minus 1? 10. 10 plus 2, 10x plus 2 is 12x. You divide 12 by 2, you get 6. 6 by 11, it's 66x. Okay, now this one here, this geometric series, the geometric sum, you can just use a calculator to do this. So, which is 0.5. So if the answer is 33.5. Okay. So 33.5 minus 0.5, what do you get? 33.5 minus 0.5. We're getting 33. 6x. 33 divided by 66. If you divide 33 by 66, 33 goes how many times into 66? 33 goes 2 times into 66. But 33 goes once into itself. 33 goes twice into 66. And this is the answer. So x is 1/2. X is 1/2. Hey, x is exactly 1/2. X is 1/2 like that. Okay, that's fine. We continue. So x is actually 1/2. X is actually 1/2. So x is 1/2. Okay, so you continue. So x is 1/2. Okay, we're done with this question. Next question. Right, so the next question is about the quadratic sequence and series, because you must also understand the quadratic sequence and series. Like in this question, we're saying we have a quadratic sequence that has the following properties. What are the properties? The second difference is 10. The first two terms are equal. That is T1 equals T2, term 1 equals term 2, term 1 plus term 2 plus term 3 equals 38. 28. 28, 28. So that the general term of the sequence is Tn equals that. So that the term equals that. Is 216 a term in this sequence? Justify your answer with the necessary calculations. Okay, let's solve this problem about quadratic sequences. So we're talking about quadratic sequences. All right. Right, so continue. Show that the general term of this sequence is this one. Show that the general term of this sequence is this one. Show that the general term of this sequence is that one. How do we do that one? Right, so to do 3.1, we do the usual stuff. We do the usual stuff. In 3.1. In 3.1. Right, how do we show that? So we proceed as follows to do this particular question. We proceed as first to this particular question. Right, so we can look at these as the second difference is 10. The second difference is exactly 10. So the first two terms are equal. What does it mean? Well, it means we have the sequence, which is x, and then T3, and so on. Or we have this. What is x minus x? 0. T3 minus x. And then if we subtract these two, you get 10. The second difference is 10. It means 2a equals 10. Right, so if 2a equals 10, because that is the second difference, you divide both left and right by 2, so you have divide by 2. Whatever you do on the left must be done on the right, which means you divide, you get 5. So the first term is, or rather the a is 5, which is what appears in the quadratic general formula, which is exactly an squared plus bn plus c. Now, if this is true, because the first two terms are equal, that's why we made them xx. They told us in the story. Now, next thing, what do we do next? We divide the page. Right, so dividing the page, we have this one. Okay, I want to mention something here, very important. So Always this one is 2a equals this. This one is 3a plus b equals this. The first one is a plus b plus c equals x. So just note that one. So which means we have 3a plus b equals 0. So we got that a is 5, so we have plus b. 3 by 5 is what? It's 15. A plus b plus c. Which is the first term? The first one is x. This one is exactly x. All right. So what do we get out of these? But also, anyway, we have been told that T1 plus T2 plus T3 is 28. So you can just use that. Let's just use that. T1 plus T2 plus T3 is 28. So what this means is that you have T1 plus T3. What is T1? What is T1? Right, it's like the first term.
Sorry, sir.
Yes, please.
When finding T1, can't we add the 5 and the minus 15 and then plus C is equal to 28, then we solve from there for T1.
Yes, we can actually you need to be obviously be very careful, but what you're saying makes sense. Okay, to say, can you just say a plus, because T1 plus T2 plus T3 is not just a plus b plus c, you know. What is T1 plus T2 plus T3? Well, it is what? Is it a plus b plus c? Well, a plus b plus c is only the first term, you know.
Oh, okay, now I see.
Yeah, I hear you. I hear you. Your reasoning is actually very, very logical. So, right. But what we have is that I think that it's easier to just use the form. We can use that as well. We can use the T1 plus T2 plus T3 and the A and the C. But it's easier to say T1 plus T2 plus T3 is 28. And then what is Tem1 and Tem2? Tem1 is X. Tem2 is also X. Okay. So, which means that in the place of term 1, we shall just put what? X. In the place of term 2, we shall put what? X as well. Why? Because they're the same. And then term 3. Right, so term 3, what is term 3 at these points? Right, so we need to reason about term 3. What would term 3 be at this point? So you need to think about this and think about what term 3 is going to be. Okay, right. So you know that T3 minus X, for instance, appears here. And if you subtract this and that, you get exactly 10. You get exactly 10, yes. Right. And so what is term 3 at this point? You need to think about what term 3 is at this point. Okay. Right. So this is what we're going to say here. Just put term 3 for now here, and then we shall get it. Okay. We need to get term 3, but first we know that x plus x is 2x. So we have that. But what is term 3? But we have therefore that from this point, from this here, 10(3) minus x. Right, 10(3) minus x minus 0. Right, so if you take 10(3) minus x minus 0 is actually equal to 10. Right, so if you have 10(3) minus x minus 0 is 10. Because it's this minus this. This minus this is 10. You know? So this minus that is 10. And this means something about T3. It means therefore T3 is actually the same as, can move the x to the other side. So it becomes x plus 10. Okay. So if you transpose, it becomes x plus 10. Okay, so you've got this formula for T3, and then you can just plug it into this one. So we have here 10(3). Okay, so it's 2x. 2x, what is 10(3)? It's x plus 10 equals 28. Okay, so we've just carried this forward and we've substituted in the place of T3, which is 3x, which is equal to 18. You divide 18 by 3, you get 6. Okay. This is quite an interesting question. But what is A plus B plus C now? Okay, because obviously you're thinking about it and you're on track. I must indicate you're reasoning very well. From these, we have that we actually need to have A plus B plus C. So let's go up. Right, from this point, we can have A plus B plus C, which you're thinking about. A plus B plus C is equal to x. But what is x? We got x to be 6. So we put a 6 here. What is A? We got A to be 5, so you can just plug that in. What is B? We got it to be minus 15 plus C equals 6. What is 5 minus 15? It's minus 10, making C equals 16. We are done with the question. We just need to write down the answer. We have already got the numerical values of A, B, and C. What is Tn? An squared plus Bn plus C. Plus Bn plus C. Which is A. A, we got A to be 5, so it's 5n squared. We got B to be minus 15. And we got C to be what? To be 16. So is that what the examiner wanted? Yes. Does it show that the general term of the sequence is 5n squared minus 15n plus 16? So we're done. We continue. We continue. Right, the next thing is we're gonna look at the next question on this here. Okay, the given information is still the same. What do you have? So we still have 216. Is 216 a term in this sequence or not? Is 216 a term in this sequence or not? Justify your answer with the necessary calculations. Okay. I'm going to give you homeworks. So, yeah. I'm going to give you homeworks. Just at the end of these, I'm going to give you homeworks you'll submit to me on the thing, on WhatsApp. So you can send me pictures of your attempts, you know. Right. So is 216 a term in this sequence? So we've done this sequence, we've studied it. We've solved the question before about it, but is 216 there? Justify your answer. Or maybe it's not there. We will remember that we have Tn 5n squared minus 15n plus 16. You get the point. This is the formula we got. But now the examiner is saying, is 216 in the sequence? So we must make this one 216. Minus 15n plus 16. And this is exactly 5n squared minus 15n. Okay, you transpose the 200 and the 216. Okay, transpose it to the right-hand side of the equation. So you have 216. You divide through by 5. And if you do, you can divide through by, before you divide, let's just add this like term, 16 minus 216. N squared minus 15n minus 200 equals 0. Okay, yeah. You divide through by 5 now. What have I done here? So this is 5n squared minus 15. The 16 minus 216 is minus 200. You divide through by 5. What is 5 divided by 5? It is just 1. You divide 15 by 5 is 3n. If you divide this one by 5, you get 40. Okay, continue. Continue. Right, in which case, therefore, we have this one, which is minus 40. Okay, if you have minus 40, just a sec. Right, if you divide 200 by 5, 200 divided by 5 is 40. I divide the board, divide the whiteboard, and then we obtain n squared minus 3n minus 40 equals 0. Okay, let's factorize this. So we have this equals 0. What are the factors of n squared? N and n. So the factors of minus 40 that give us minus 3, you said they must add up to minus 3, and they do. The two numbers minus 8 and plus 5, they add up to that. Okay. Right, let's see. All right, so we get this. So what are the factors of this? So n minus 8 into n plus 5. So which means that n equals 8 or n equals minus 5. And therefore, the number of terms cannot be negative. They cannot be negative. So the number of terms can only be, we can speak of 8 terms than minus 5 terms. So, and this actually, it is telling us that the 8th term is actually equal to 216. It is telling us that term number 8 is actually the 216th term. Term number 8 has the numerical value 216. There are certain things we need to learn and need to understand. We need to understand graphs and functions. Graphs and functions remain part of the curriculum, and they must be understood, and they must be known. How do we interpret graphs and functions? We look at this particular question here. Given the function p of x equals 1/3 x to the power x, is p an increasing or decreasing function? How do we know? So we learned some basics here on the graphs and functions. So the graphs and functions can be written in the form a to the power x. So there are two cases when a is bigger than 1 and the base of x is bigger than 1. So we have an increasing function. So if you have a to the power x, 1 less than a, 0, yeah, 0 less than a less than 1. So if the number a at the bottom lies between 0 and 1, like it's 0.3 or it's a fraction that is smaller than 1, then you have a decreasing function. So is p an increasing or a decreasing function?
Decreasing.
Well done. Thank you so much. Thank you so much. Well done to you. So it is actually a decreasing function. It is a decreasing function. Excellent. Well done. All right. So we move to the next question. Right. We need to determine P inverse. So there's certain things we call inverse functions that we need to understand. What is the inverse of the function P of x equals that? Right. So to find the inverse, it's easy. We first write to the given function in the form y equals 1/3 to the power x. So I'm going to give you a homework on graphs and functions and the things we did together today. So now we write this one in the place of p, you can just put y there. Y in the place of y, now for the inverse. So in other words, this one is the graph of p. And then the graph of the inverse of p, we can interchange. So in the place of y, you put x. In the place of x, what do you put? You put y. Which means, therefore, you can make y the subject. Or it is exactly x base 1/3. So we can solve for x at this point, but if we solve for x at this point, rather we solve for y, we make y the subject. So what does it become? It becomes y equals the log of x base. So the base of the exponent, so the base here of the power 1/3 to the power y is this. So what do we get out of this? So y is equal to log x base 1/3. Determine P inverse in the form y equals that. So which means, therefore, you can write it like that. So what is the answer? The answer is y equals the log of x base 1/3. Okay, so in other words, this given one is called the exponential function. Is done in grade 10. Exponential function. Right. Whose inverse whose inverse is the logarithmic function. Logarithmic function. So you need to note that. Right. The inverse of the exponential is the logarithmic function. What is the rule here? I need to mention the rule before we move to the next question. We've already answered this question and the answer is there. But what is the rule? So there is a rule we use here. What is the rule? The rule is if you have, for instance, y equals a to the power x, we can make x the subject. How do you make x the subject? So x becomes the same as the log of y base a. Log of y base a. So this is what you have. So in other words, in mathematics, these things are the same. So you can make x the subject of the equation. This is called the exponential equation. But how do you make x the subject of the equation? You just put the log, you write it like y equals a to the power x. The power x is on the right of the equation. And then you put log y, the base of the power becomes the base of the log, log, and the log is the what you call the logarithmic function. Okay. So we have this. Write down the domain of P inverse. What is the domain of P inverse? Right. So the domain of P inverse would be an interesting one. Have you ever seen domains before?
Yes, sir.
All right. I know this is going to be tricky to you. What would the domain be of this one? Right. So obviously there are a couple of things that you actually need to consider at this point. Right. So, but what is the domain of these here? So the domain of these would actually be the values of x for which this function itself is defined, right? So for what values of x is this function itself defined? Right, so remember the inverse function. This is the p, but it has a domain. What is the domain of this function? Okay, the domain of this function is all the real numbers. So we know therefore that the domain of these is all real numbers. But now we will focus also on the domain of the inverse function, just in a second now. Right, so the domain of the P is x is in the real numbers. But you remember that the inverse function, we got it just now, it was the log of x base 1/3. Okay. Now, what is this? What is the domain of this? Okay, this is the log function. So the domain of the log must be such that the log only is defined, it has real solutions when x is greater than 0, but also when x is an element of the set of real numbers. Write down the domain of P inverse. Well, the domain of P inverse is x bigger than 0, and x is an element of the set of real numbers. Okay. So this is the domain of the inverse function because the log is defined for positive numbers which are real. Given the same function, write down the equation of the asymptote of this function. Okay, this is done in grade 10, but we're revising it now because it's part of grade 10 is part of the FET phase. FET stands for Further Education and Training phase. So what is the equation of the asymptote of this? Okay, so we're going to look at the P of x minus 5. So, and that would mean we're dealing with P of x minus 5, which is the same as 1/3 that minus 5. So what is the domain of this? Rather, the equation of the asymptote of this. Okay, the exponential function always has an asymptote. At grade 10, you were taught about y equals a times k to the power x. Okay, let me use the grade 10 symbols. Okay, the grade 10 symbols are of the form. Normally, you're given y equals a times p to the power x plus q, something like this. Okay, so the y equals q is the equation of the asymptote. Okay. So write down the equation of the asymptote. So it is y equals minus 5. And that is the answer. Y equals minus 5. Y equals minus 5. Write down the equations of the asymptotes of f. The equation of the asymptotes of f. The equation of the asymptotes of f. What are the equations? You remember this one? It's called the rectangular parabola. So the asymptotes occur when x minus 1 equals 0. And this means that x equals 1. Okay, and this x equals 1 gives us what we call the vertical asymptote. Right, and then you also have y equals 2. This one, which is the horizontal asymptote. Okay, so if you have y equals 2, which is the horizontal asymptote, and x equals 1, which is the vertical asymptote, because the question said write down the equations. So we're dealing with equations. There are two of them. There are two equations of the asymptotes of f. Next question. We must be able to, let's take part of the grade 11 requirements, calculate the intercepts with the axes. Like your x-intercept and your y-intercept. What is the x-intercept of this? What is the x-intercept of this? Right, so as part of the solution, we want to do the x-intercept, right? You must let y be equal to 0. So if y is 0, you have this. Or then you have this x minus 1 equals minus 2. You cross multiply here, which means minus 2 into x minus 1, which means 4 into minus 2x plus 2, which means that you have 4 minus 2 equals minus 2x. What is 4 minus 2? It's exactly 2 equals minus 2x. Okay, you can divide through both left and right by the number minus 2, the coefficient. So if you divide the left by minus 2, but also you divide the right by minus 2, you get the answer. And the answer is exactly minus 1 equals x. So x equals minus 1. Once you get x equal to minus 1, and this is the x-intercept of f. Okay, this is the x-intercept of f. All right, so the x-intercept of f can also be written like that, or you can say when x is minus 1, we have that y is 0. So the x-intercept has the coordinates minus 1 and 0 is a point. It's a point on the x-axis. 2 marks, you got that. Right, in 4.2.3, it's very important that you're able to sketch the graph of f. How do you sketch the graph of f? Right, so to sketch the graph of f, there are a couple of things you need to consider. What do you need to consider? Right, you have already got the x-intercept, but now what is the y-intercept? What is the y-intercept? Right, so to do the sketch, you will have to determine something called the y-intercept, which we did not do. Okay, what is the y-intercept? So you need to let x be 0 here. Zero minus 1 plus 2, which is minus 4 plus 2, which is minus 2. When x is 0, this is 0, y becomes minus 2. Okay, when x is 0, y becomes minus 2. Now, you need to be able to sketch the graph of f and label all asymptotes and indicate the intercepts with the axis. Let's sketch together. Right, so we need to first draw the coordinate axis. We draw the y-axis. And you need to draw the x-axis as well. And now you remember the vertical asymptote is at x equal to 1. And then we have y equals 2. So you have y equals 2. And then x equals 1. Okay. Vertical asymptote is x equals 1 and the horizontal asymptote is that. So we know that the y-intercept is at minus 2. And the x-intercept is, we got the x-intercept at minus 1. So now we can sketch the graph. So to sketch this graph, it's going to be like this. So you have this. For this one here is f. So this is the graph. Okay, you need to sketch the graph of f. This is the graph of f. We sketched it and we labeled it as the graph of f. But also you need to be able to label all asymptotes and indicate the intercepts with the axis. Indicate the intercepts with the axis. Okay, we have shown the y-intercept and the x-intercept there. Okay. We have this exactly. Now we continue. Next question. Right, use your graph to determine the values of x for which this is true. The values of x for which that is true. Okay, what kind of a marmal is this? Well, it's the transposition of the terms, because if you have this now, you bring the 2 to the other side, and this is greater or equal to 0. So you have transposed the -2, and then it became +2. What is this? Okay, you have to remember the graph a little bit. So the graph is like this. Y-axis and the x. So you have this. You have that. So you have this and you have that. Okay, need to draw it carefully. Need to change the bottom part. This part here, I need to draw with much caution, so it must cut it through there because it cuts through -1 for x and it cuts through -2 for y. Okay, if this is true, what is x? Okay, look, you need to use the graph to determine the values of x, which is true. So this is, we transposed the -2, it became positive, and therefore this means f of x is greater or equal to 0. If f of x is greater or equal to 0, we're dealing with the part where it's greater or equal to 0. Okay, so you have this. So this one is f here. Or if this is greater or equal to 0, the part of the graph where it's equal to 0 is here. Equal to 0 is on the x-axis, and then greater than 0 is this part. But also greater than 0 is that part. So greater than 0, therefore, it means, therefore, x is less or equal to -1. So x is actually, because it's 1 here, so x is bigger than 1. Okay, because when x is bigger than 1, the graph is here. When x is equal to -1, less than that, it is there. So x is less or equal to -1, or x is bigger than 1. Okay, we have to use the graph. So we use the graph to determine the values of x. But this question can be done without using the graph, but the examiner was more particular here. They said use your graph, so yeah, okay, like that. Next question. Right, in 4.2.5, determine the equation of the axis of symmetry of F. How do we find the axis of symmetry of F? That has a negative gradient. This is grade 11 work. So anyway, we must first deal with this. f of x minus 2. So what is that anyway? What is that anyway here? So you have that f of x is 4 over x minus 1 plus 2. So x minus 2 is 4 over x minus 2 minus 1 plus 2. So it is 4x minus 3 plus 2. So you have the point. There is a point that is going to have 3 and 2. So x and y. Where the asymptotes intersect. And therefore, y for is 3, 2, xy. Negative gradient means you have minus x plus c. Y is 2. X is minus 3. So y is minus x plus 5. So what is the equation of the axis of symmetry? It is exactly minus x plus 5. And obviously we are looking for the equation of the axis of symmetry of f of x minus 2, which is this one here. In other words, it becomes a translation of that function by 2 units. If you subtract, the graph is translated by 2 units to the right, 2 units to the right. Okay, so we have that kind of a transformation of the graph. And the answer for the equation of the axis of symmetry is minus x plus 5. Next, we have question 5. Question 5 is about more important things, but more graphs and more graphs and more graphs. Okay, so we shall look at the coordinates of the turning point, the range, and so on and so forth. Let's start by doing 5.1. We need to actually be able to write down the coordinates of the turning point of F. To write down the coordinates of the turning point of F, we proceed as follows. How do we write down the coordinates of the turning point of F? Right, first things first, so we have the function f of x, which is minus into x plus 3 plus 4. For what is this? Ordinarily, we need to write this in the form. So what is the turning point? It's minus 3, 4. Minus 3, 4. So minus 3 and 4, minus 3 comes from there, the 4 comes from there. And these become the coordinates of the turning point. So what are they? In this question here, the coordinates of the turning point TP are actually minus 3 together with 4. Right, 5.2, we need to write down the range of F. What is the range of F? Right, the range of F will therefore obviously be a mark from the telling point further down. So what is it? We have learned that this one is -3 and 4. What is the range? So you have 4 downwards. Right, so the range will start from 4 and go down. So you can write it like that. Or you can say it goes down, so it like goes to minus infinity. So the range will therefore become y is an element of the interval to minus infinity from 4. And write it like that. If you don't want to write your answer like that, you can write it as y is less than or equal to 4. So if y is less than or equal to 4, we have that. Okay. So show that the coordinates of A and B are -5 and -2 respectively. Show that the coordinates of A are those. So obviously you have these and that. Right, so the coordinates of A and B are basically the points of intersection. So in 5.3, we're dealing with the points of intersection. Okay, we equate them. So we make f to be equal to g. So we make f of x to be equal to g of x. So if f of x is equal to g, this is what we get. Okay, we square this one. So if you square this, it becomes exactly x squared plus 6x plus 9 plus 4 is equal to x plus 5, which is minus x squared minus 6x minus 9 plus 4 equals x plus 5. So which means you have minus x squared minus 7x. What is minus 9 plus 4? It's actually minus 5. If you transpose the other one, it's going to be minus 5 minus 5. Minus 5 minus 5 is actually minus 10. Divide through by the negative, which gives us x squared plus 7x plus 10 equals 0. So the factors of x squared are x and x. Factors of 10 are plus 5 and 2, which 5 plus 2 gives 7. And therefore, x becomes minus 5, or x equals minus 2. So we have this. We have this. All right, so what are the coordinates therefore of A and B? So clearly we can see that the x coordinates of A and B are minus 5 and minus 2 respectively. Okay, so we get exactly those there. The next question. So in other words, I'll just comment here. It means here it's minus 5, but it means the x value here is minus 2. The graphs of the functions f of x and g of x are drawn below. The graphs intersect at A and B, hence determine the value of C. Okay, so how do we find the value of C? For which this equation has one negative and one positive root. Right. So we look at this exactly. We look at this exactly and what is happening here. And what is happening here. So the question is, what is the value of C here? For which this equation has one negative and one positive root. So you need to look at this and think about it. Right, you need to look at this and think about it, but very carefully. Because this here means the two graphs are equal to each other. When are the two graphs equal to each other at this point? See, they're equal to each other at some x value. We saw that at the point of intersection, this is -5, and we saw that this is -2. But what is the value of C at this point for which this is true, such that these two functions are equal to each other? So what does it mean? It means basically x has been replaced by what? By x plus c. If you replace x by x plus c, we agree at this point that here our x lies between -5 and -2. Okay, x is the variable that lies between -5 and -2 there, and so that is what we get. So what is happening exactly here? So we note therefore that the graph must shift more than two units, more than two, and less than 5 units to the right. We note that the graph must shift more than 2 units. The graph must shift more than 2 and less than 5 units to the right. Okay? So that we have one negative and one positive root. Right, so if the graph shifts more than 2 units and less than 5 units to the right, it means therefore that our C will therefore lie between -5 and -2. Okay, that way. Because if this here has one negative and one positive, we understand therefore that these two are equal to each other. So if the graph must shift more than 2, because it is at -2 here. So it must at least shift more than 2 and less than 5 units to the right. More than 2, because if it shifts 2 units exactly, then it's going to be here. This point 2 units to the right is going to be exactly here. Right. And therefore the graph must shift more than 2 units and less than 2 units to the right, or less than 5 units to the right. So it means our C will actually lie between -5 and -2. Think about this question and make sure you understand these. We move on to the next question. We still have the same graphs, F and G, and they've been drawn here. We already know the graph. Determine the maximum distance. So we're looking for the maximum distance between F and G in the interval XA and XB. So we have XA and we have XB. Okay, we're about to conclude our lesson. Okay, the maximum distance between F and G in the interval that is K. So the maximum distance in the interval there is K. Okay. This is K. If it is given that if H is G of X plus K, determine the equation of H in the form H equals something. What is the equation of H? Right, so we continue to solve this problem. Right, but first things first, we realize the distance. So the distance is f of x minus g of x. And this is, what is f of x? It's exactly this. So f of x is x plus 3 squared plus 4 minus g of x is exactly x plus 5 d of x. Okay, what is this here? 9 plus 4. So which is minus x squared minus 6x. You multiply through by the negative, you distribute. That is called distribution. Minus 9 plus 4 minus x minus 5. Which means d of x is minus x squared. Okay, 6x minus 6x minus x is minus 7x. So we have this. So we're looking for the maximum distance, and therefore we can use any of these. So for the maximum distance, x equals minus b over 2a. Our b is minus 7. Our a from here is minus 1. Okay, and therefore the result is 7 over minus 2. Okay. So we got therefore that x is 7 minus 7 over 2. So thus we have the distance, which is minus, which is square this. So you plug it into the d of x equation, which is minus that, minus 10. Okay, so you manipulate everything. which is the same as, okay, if you use a calculator here, you'll get that this is exactly, you'll get that this is exactly equal to, right, so you get that this is exactly equal to 2.25. Remember that we said the maximum distance between F and G in the interval is K. So which means that this distance is K and K is 2.25. If H of X is G of X plus K, determine the equation of H in the form. So which means therefore the equation of H is G, which is 2.25. Okay. But now you need to add, remember, you add G. So it is exactly G, but obviously you need to write the equation in full. So you can write it here, which means H of X is G. What is G? It's X plus 5. So you put X plus 5, but you put 2.25, which means H of X is X plus 7.25. X plus 7.25. X plus 7.25. That is the answer. Okay. And so we have solved this problem. Right, I've been watching the time very closely. Right, our time is exactly 14:12. Right, our time is exactly 14:12. But the discussion started earlier. It started about 12 p.m. So we're doing very well. So it's time to take a break. Right, so we're going to take a break from now, 14:12. Right, I think that it's ideal I give you 1 hour break. 1 hour break. So it's going to be up to 15:12. So we're going to start at this time. But the system is going to be online by 3 p.m. by 15 hours. We're going to be online to start at 15:12. Okay, so thanks a lot. I'll send you the link to the video in a couple of minutes. Within that 1 hour, I'm going to compile the video and send you the video so that you're able to watch the discussion we had today, and you can watch it throughout the year. Right, so yeah, 1 hour. Okay. So
Okay, sir.
Yeah, thank you so much. Any question?
Also, must I leave the meeting and then rejoin again, or
Please come again.
should I leave the meeting and then
Yes,
rejoin?
yes, definitely.
Okay.
So yeah, now you need to leave the meeting, go and drink water, go and enjoy yourself, go and stretch in the fields, soccer fields, play soccer, and then be online at 3:12. Okay.
Okay, sir.
Okay, thanks
Thank
then.
you.
See you then. All right.